Hi, everyone, and welcome to another episode of this Test Automation Meetup. And again, we will thank Testomeet, Testomat.io for sponsoring us and bringing you guys all these lovely people that we find and who come and talk to you and give you insight into what's going on in the real world as we speak. So today, we have two speakers. I have Wes Nishio, if I pronounce it right, he will correct me later on, and Jonathon Wright. Just to let you know, Jonathon Wright has some work-related stuff and he can't be here, but we have his whole presentation recorded, and we will play that for you after we hear from Wes. Okay, so as you know, I am Larry G. They call me. I'm Larry Goddard. I'm the creator of klassi-js, and I am also the test automation architect for the press, for Oxford University Press. And I take this time to highlight and bring these lovely people, and then I will ask you all the questions that you have. If you post them, I will then ask the speaker to do it. So without further, I will introduce Wes. Wes is the founder and CEO of GitAuto, which is a QA coding agent that lists untested files and generates test case PRs within 10 minutes of doing it. So Wes is with us today, and he is going to give us a nice little insight into how to improve your test coverage with a QA agent. And Wes, good afternoon.
Hey,
How are you?
good afternoon, Larry. Thank you for inviting me.
Yeah, pleasure. So I'm going to just leave you now to introduce yourself to everybody, and then go on up. But before I do that, how would you like your questions to be? Do you want them? Do you want me to tell you what they are as they are presented, or do you want to wait until the end of your presentation?
Yeah, well, sorry, can you say that again?
Oh, I'm asking. Normally, the audience have questions, so I want to know if I could ask you with while you're presenting, or wait until the end of
Yeah,
your
sure.
presentation.
Sure, yeah. Well, while presentation, feel free to drop any comments, and Larry, you can pose me anytime.
Okay, that's fine. So without further ado, people, here we are. Wes, it's all up to you. Thank you.
Thank you very much. Should I get started? Yeah, just hold on. Oh yeah, nice. Can you see my screen, Larry? Guys.
You can see a screen.
Okay, so good morning and good afternoon, everybody. Thanks for joining. I'm Wes, founder and CEO of GitAuto. GitAuto is a QA coding agent to improve test coverage and by generating test cases for S3 managers and QA managers. So today we're going to talk about test coverage. That means, as you know, like how much of your how much of your core actually runs during automated tests. So we look at how a QA coding agent can help improve that coverage without needing to grow your team. By the end of this session, you understand how test coverage is measured, a simple workflow you can try as soon as today, and real examples from engineering teams and that have already improved the testing using this approach from my customer perspective. Uh, if you have ever spent a Friday night rolling back a hot fix, this session is for you. Okay, a little about me, so you know the voice behind the slides. Um, so again, my name is Wes, and founder and CEO, and which is a QA coding agent. Um, Before building this QA coding agent, I spent years inside other people's product and projects. And one project in particular shaped my thinking. It was decade old SaaS product written in PHP. Automated test coverage was literally zero, as you know, and CFR, change, which is a change failure rate, the percentage of deployments that cause an incident or rollback, hovered nearly 100%. It was, yes, it was true, and meaning each release introduced at least one new bug, and team adapted to the chaos instead of fixing it. The engineers brace for bug alerts, and the sales representatives learn, just learn to click around broken features during their demos. And the customer support projects so often they kept scripted responses handy. And executive asked for root causes, but the only proposal there was just handwrite a massive test suite, and we had to resolve this by just adding headcount at the time. But now the feasibility, and thanks to technology, it looks completely different. I started this business because I personally experienced that, to give teams still living that old nightmare, a fast, affordable pass from firefighting to predictable low-risk releases. Okay, here's a roadmap for today. What is testing? So, we start by covering the fundamentals a little bit. What is testing? Why do we need that? How do we evaluate that? And what is test coverage? And what is test coverage report too? And when and how is test coverage report generated? Then we'll introduce AI agents and GitAuto specifically. And so what is AI coding agent, by the way? And what is a QA agent? What exactly GitAuto? And reusable test prompts as well. And then we dive into the practical demos, actual live demos, and writing unit tests and API integration tests, database integration tests, and component and A2E tests as well. And lastly, we will finish with open Q&A. You can drop your any comments, and Larry can stop me. But at the end, we're gonna have a open Q&A session as well. So, what is testing? As most of you, are also experts, so you are familiar with it. But some of you might not be familiar with whole fundamental things. So let me dig into a little bit deeper. So when we talk about software testing, there are two broad categories usually discussed: manual and automated. And manual testing is like scripted manual testing. It's literally scripted testing. And exploratory testing, aggressively to find a bug. And ad hoc testing, it's for like reviewers, and not planned, like not predefined testing, but reviewers usually do this. And user acceptance testing as well. On the other hand, automated testing generally falls into three main types: unit tests, and integration tests, and the E2E tests. Unit tests basically check small, isolated pieces of code, and typically individual functions or methods, and they are fast, numerous, and crucial for catching basic issues early. Companies like Amazon even automatically brought pull requests that don't include adequate unit tests, demonstrating their importance. And also, integration tests verify that different components or modules work correctly together. For example, unit tests might mock or simulate external API responses, but integration tests actually make that real API calls and confirm real-world interactions, right? And E2E is simulate entire user workflow, like signing in and signing out and making a payment, installing a software and uninstalling a software, like something like that. Okay. And the important point here is balance. So I'm not saying, manual testing is isn't valuable. It absolutely is. Humans are still very great at finding nuanced and unexpected issues, but relying solely on manual testing isn't also scalable or reliable long term. So balance is important. And let's talk about why, for those who are not, implemented automated testing yet. So why uh, is it important? So there's two big reasons: and quality and time and cost. With the quality side, automated tests catch bugs early, before production they reach, before they reach users. That leads to smoother experience and fewer public issues. Also, this is also important for, developer perspective. Psychological safety. As your code base grows, you often you have to edit code and you didn't write. Without, automated tests, developers or you feel anxious or about breaking things, and this leads to delays or overly cautious development. But without reliable tests, you get immediate feedback on comment on push request. If something breaks, you fix and move on. You know, and your test suite becomes a kind of living documentation. Yeah, that's just that. Third point. I like reading docs, which often go stale. Tests stay, it, literally current by design, because if your code doesn't behave as expected, the test fails. That makes tests the most reliable documentation you have. The other hand, and one more thing, the other important thing is time and cost. uh, Obviously, automated tests are really fast and repeatable. What takes hours, manually can finish in just seconds. This means less manual efforts, and your team can spend more time building features. And actually, literally, manual testing on every commit is almost impossible. This also and accelerates your release cycles as well. You know, without automated tests, you have to batch your changes or releases like a per month, releases, and infrequently, but with automated tests, you can just test, every commit, like I mentioned many times, and on merge event as well. So you can release very frequently and confidently as well, right? And yes, that's a little overall, but uh, people or developers usually, like, want to skip manual tests after just a small addition or changes, but machines don't care about it. So automated tests run literally every time, every comment, even just after tiny tweaks. So, and they scale. So whether your team has two engineers or 200, the tests run in parallel. Yeah, sorry, that was the fourth point. Okay, that was the reasons why we need automated testing. Okay, so how do we evaluate that? So now suppose we start implementing automated testing, and how do we actually measure our progress, and how do we know if we are doing good, good enough testing, or if we need to improve? So the most practical way is track test coverage, right? And the most teams, when they say coverage, really talking about statement coverage. which is also called line coverage. It tells you what percentage of your executable code is being tested. And there's other complementary two types, function coverage and branch coverage. Function coverage is literally function coverage, and just checks how many functions get called and how many callable functions get called. And the branch coverage is just for if statements. You have true or false, two branches, two passes, and if you run execute that both conditions, then you're going to have 100% branch coverage. Of course, we have another test metrics to evaluate your test suites, but basically test coverage is a king at this moment. It's because simply simple, right? Yeah, that's right. And if you don't have a coverage goal yet, maybe you don't have, and just pick one and say it aloud, add it to your pipeline, even if it fails at first. That's part of your process. All right. What matters is making progress. Okay. And go to the next page. So what is test coverage actually? How is it being calculated actually? So for example, like statement coverage, in this case, I'm on the right side of this slide is a small Python function from my own repository. The whole snippet is just 18 lines. So let's use it as just a simple example to see how test coverage works. And statement coverage measures only executable lines. So it typically ignores, on the top side, imports at the top. And for example, lines 1 to 13 are mostly imports of blank lines, and so they are skipped. So line basically 15 is just is not callable, just a definition statement. So line 16, 17, and 18, and also 14 is a decorator, and which is also executable. So they are the target of testing. So 4 lines in total in this case, right? And if you run all of the 4 lines or statements, then you're going to have 100% test coverage for this file. Easy. And also, function coverage is much simpler than statements. Just it counts, just one function, one definition in line 15. And so if you call this function in your test suite, and you want to have 100% function coverage. Okay. And for branch coverage, if you covered each possible condition path, like both true and false branches of an if statement, in this function there's one conditional if not URL on line 16, giving us exactly 2 possible paths. If your test exercises both possibilities, you achieve 100% branch coverage. Okay, and now this is a test coverage actual report, it looks like. And have you ever seen that? This is typically coverage tools provide multiple formats, like detailed HTML formats, and which are very human friendly. But it's hard for AI to parse because there's a lot of unnecessary decorating for humans. So basically, AI agent servicer like us, we use we parse edit code format. Have you ever heard of it? Line coverage format reports, which is basically generated by almost all programming languages. And because this is, like you see, very plain format, it's minimal, standardized, but it's easy for AI system to consume. So code file and that report is widely supported across various languages and AIs right now. And when and how is that test coverage report generated? So maybe some of you have not implemented CI/CD pipeline. In this case, I'm going to introduce like a GitHub CI/CD actions workflow using a YAML file. This is the YAML file. So first, okay, this one. So this is a trigger. Can you see that? So usually you push event or pull request event, whatever as you like. Then test run inside, or basically somewhere. But in this case, GitHub's own infrastructure, which is actually a Microsoft Azure, or sometimes AWS Lambda or something like isolated infrastructure. Some people think about AI agents like GitAuto could run tests on their own infrastructure, and technically it could, but because we use AWS Lambda, but it's much easier and safer to use GitHub, just like human developers do, right? So human developers usually use this CI/CD. So AI agents is also leverage existing technologies as well. And third, so in this here we run PyTest, for example, and with coverage flags, with coverage reports generation. Because usually CI/CD isolated independent environment is temporary. So we have to upload the coverage report generated in this environment as other external services like GitAuto can access to the report. So we need to, for example, upload it to the GitHub artifact, which is like Amazon S3 bucket, where it's accessible to other from other external services, right? And fourth, this is one. Fourth, you need to upload the coverage report to the somewhere accessible. Okay. So the last in the last half, we covered the fundamentals of automated testing, and now let's dive into the solutions. So so basically these are all AI agents for coding agents, right? And but different types of AI agents on the left side, as like you have Copilot, Cursor, Windsurf, Lovable, many AI. This is called basically IDEs or AI pair programmers or AI chatbots on IDE. So basically, and I use that too, but you need to ask something on your IDEs, because basically you might have ongoing changes, and humans usually do. But if you ask them as an agent mode, they are allowed to edit all of your files, including your on the files you still have, you still making changes, right? It's a bit risky to allow them to be agent mode. So this is why these days, fully autonomous AI agent is on the cloud side and server side, and that's AI full stack coding agents like Devin, from Cognition Lab, and so sorry. Yeah, so but AI agents so started as a full stack engineers, but if you so it's like but like human developers have done this for years and years, just like in real developers, generalists and full stack engineers aren't always the best choice, because specialists, like QA coding agents, often outperform them, just a single, focused areas. So I believe AI agents will, or or AI full stack engineers or AI full stack agents will evolve the same way like human engineers did, towards specialization, right? So that's where the real impact will come in. So we see the rise of the specialized QA focused coding agent, just as QA engineer role in human teams has evolved into more specialized positions, right? And GitAuto is especially focused on unit and integration testing. Unlike other, YC-backed companies like Spoo or Momentic, they are more focused on like E2E testing. There's a completely different users and job titles and customer base. So we are, each players really dive deep, dive deep into details. All right. So how GitAuto works? So GitAuto can be triggered by several types of events, including like manager assignments, on-call comments, and on-merge pull request events, or schedule time. But let's look at the basic scenario. The manager assignment trigger first. So it creates a the dashboard, with your repository every files with low test coverage. So you can, which file is still a low test coverage and then you need to improve. And you can just say, select and then specify targeted files, and you can, allow or get GitAuto create issues for that, and for the pull request for that. And GitAuto using GitHub, and based on the generated code base and test cases, it runs tests as well on your GitHub repository. And if they fail, it's self-correct as well. And only you have to do is just review the PR. And if you don't like that, test results or code changes, just go back to the issues and where your instruction can be modified, and rerun this coding agent until you can, it looks good, and you merge the pull request. Okay. All right. So let me Oh, finally, before we starting writing the actual test cases, just let me give you the reusable test prompts as well. So first one is, test coding it rules, functions or classes or descriptive, the one in the descriptive test name or, variable names, or you prefer concise ones. And also, you want to mock external APIs or real dependencies. And for test cases, only happy paths, or you want to cover all edge cases as well. Comments or no comments, reference URLs or no URLs. These are, all requirements from your side. So you have to explicitly explain what's your preference to AI agents, right? And also file paths. If you want to place newly generated test cases into test directory or next to the source, each source file and file name. So what looks like looks like, test original file or original file underscore test. You have to specify. And also constants. Tell GitAuto or AI agents just where commonly or frequently used constants is. Like for me, GitAuto is a GitHub application. So obviously we use GitHub APIs so many times. So I tell my GitAuto coding agents, where's the repository constants or where's the GitHub tokens, something like that. So that's, constant rule. You also you have to specify explicitly. Okay. Okay. Now it's time to for me to demonstrate the real code, real test cases. So let me go into. I need to just hold on. I need to change my share screen. I think I'm gonna share my window. Am I? Larry, am I sharing my entire window?
Yeah, yes, you are.
Okay, thank you. So this is a dashboard where you can find your every file in your repository. In this case, GitAuto organization. Under GitAuto organization, I choose GitAuto repository, and all the files under GitAuto repository is here. Okay. And so that you can basically in your repository you will export on every file what they are, and you just pick any files you want to improve your test coverage. In this case, 50% in statement coverage, but this file, relatively easy. If that's the case, I would choose this and actions and create issues or create issues and the PR at the same time. That's what you do basically. Okay. And in this case, okay, I'm gonna choose this file for maybe I've already, yeah. This file is very easy one, and the statement coverage is 90%, and the function coverage is already covered for some reasons, and branch coverage is not covered fully 100%, maybe true or false, maybe true cases is only covered, which is interesting. So I'm gonna check this and create issues like this. And in a few seconds, issues created successfully. So you go to the issues. Can you see my GitHub screen? So GitAuto wrote down on behalf of you about this file and test coverage reports and all the information about test coverage, and also specifying uncovered lines is 18, which is, it's a bit hard for human to specify every time. So maybe this is will save your time as well. And also branch coverage, which is a bit complicated for humans, but it's already specified as line 16 and broke 0, and this is how it jumps. So maybe it indicates true cases or false cases. And also the basic instruction is already pressed here. Try to achieve 100% test coverage with minimal code changes, right? So only you have to do is just assign GitAuto to this issue by checking the checkbox. Let me check the checkbox. Okay, and in a few minutes, in a few seconds, let me just oh yeah, GitAuto has already GitAuto has already started working on it, on these issues, right? This is a live log. So basically let me see this way. So exploring your entire repository, and found how many files in your repository, and also went through all the possible configuration files, like Docker or requirements.txt, which is packages files for Python, and also went through issue comments, if any, and then if there's no problem, just move on and create a branch and start it to search entire repository by using query. In this case, he tried to identify this test underscore slack.py, which is this time targeted files, and the test file is already existed or not, and this time not. And also it tried to search all possibly relevant files inside the repository. So it's like a almost autonomous agentic behavior. And unlike cursor, cursor tried to a little bit sabotage to explore entire repository, even if all the files in your local IDE. But GitAuto or coding agents try to explore everything or every related files in your repository as much as possible. That improve the quality of the output. In this case, test cases quality is dramatically improved. Okay, so now generally speaking, it takes 4 to 5 minutes. So I'm going to jump to the already created ones. So let me go to the, yes, this is the pull request which is already generated. And go to the, sorry, I need to, so original file was like this. As I showed you earlier, this is a original file, targeted file, right? And just this part is a function. Very simple. Receiving text and make a request call and post call and then passing the text to Slack webhook URL. That's it. And what is the code changes and test cases look like? Here's the one. So this is a test case, test Slack success, happy case. And also, if this, Slack webhook URL was not set, which is, I think, error case or edge cases. And also request method, outputs and errors or exceptions. This is also error cases. And request HTTP error cases as well. Okay, so one happy pass and 1, 2, 3 edge cases, right? So and the test results. So test cases are immediately run after opening this pull request, thanks to the GitHub CI/CD, and which was showed here. And as you can see, it says it shows is a green check, which is all the test cases are passed, right? So if the test cases here, if they looks good to you, and also test cases are passed successfully, and now if I are manager of this repository, I can just merge this pull request. In theory, it took 4 minutes to 5 minutes, and the review it's gonna be a few minutes more. So let's say 10 minutes in total, right? And you're gonna have 100% test coverage test cases for a file. That's how AI agent can do these days. And this was a very simple use case. So let me go to the next one, API integration test. So go to the dashboard again. And is forked? No. Oops. I might have already merged it, maybe. Let me check. Just API integration tests. You have proposed services. Sorry, I spell miss. Okay, got it. So this one is to check if a given repository is fork or not. Very simple, right? So I'm gonna create issue for this file. At this moment, this statement coverage is 50%, 0% function coverage. Branch coverage is 100%. Maybe your if statements is not there. And go to the issues. See, the targeted file is like this. Very simple. Just call the API and check the parameter. That's all, true or false. And it's already predefined. This one. So, and the test cases, generated test cases is like this. One test case is one function. So 1, 2, 3, maybe 3 was there. So 4, 5, 6, and that was a unit test, and this is an integration test. Integration test looks more clear, like 1, 2, 3, 4. So 6 unit test cases and 4 integration test cases. So 10 test cases in total, with just one click, and GitAuto generated all the test cases. All right, and this was interestingly at the first try. I think we made some mistake, and test suite, newly created test suites fail. So I just gave him error log, just a copy and paste, and GitAuto reworked on the error log and made additional comments, and we resolved the issues. Now all the test cases are passed successfully, so now I can merge it. That's all. That's integration test cases as well. And also for database, the same. Just go to the dashboard and pick the database files here, and go to this is results, and you can see the test cases. This is very simple. I think I have instructed to simplify the output. In this case, one success case and one error case or edge cases for integration testing, right? And it's also the test cases, two test cases in total. In this case, are already passed successfully. So now I can merge it too. And lastly, it can create a component UI and E2E testing as well. So let's see that too. So go to the dashboard as well. And this time I'm going to choose website and install the button. Oh, oops, sorry. So go to install button. Button is not here. Why? Install. I already. Oh shit. Let me try that again. I need to do this. So yeah, here. This is a components button install. Yeah, I think I have just tested myself, and then, but still I can choose it and create issues, and then you can see that. And if you want E2E test as well, just just let him know that here. You can put any comments here, and so that he knows it, and if he follow your additional instructions as well. And the results here. So see, this is a unit test or component test for this file, and also not this one. Install. Let me go to the pull request again. No file change. Yeah, this one. Sorry. This is a unit test for this file, and yes, this is E2E testing, which is located in the different file paths. Okay, and it's also yes, expecting this button. If you click this, it actually bring you to the specified URL or not. This is absolutely E2E testing. So I think I already covered almost everything. Just hold on.
Uh, so you went through everything, and how do you could you tell us how do we integrate uh, that into how do we integrate GitAuto into our project?
Yes, thank you for your questions. And it's easy. This is a GitHub application. So just go to, can you, I'm still sharing my screen.
No, you're not sharing the screen anymore.
Okay, so let me do
So it's
that
a
again.
module. So it's a module where I go git add and add it into my project.
Yeah, exactly. It can be added to your repository by installing GitAuto to just, go to.
So it's a dependency. I use it as a dependency. Yes.
Yeah, that's a great question. So when running tests, all the dependencies is also necessary, but it's installed into your GitHub Actions and CI/CD environment, and which is defined in your YAML file.
Okay, so it's not a project based thing. It's all inside my GitHub Actions in the CI/CD.
Exactly. And GitAuto just behaves like your human engineer and try to access your GitHub, under necessary permission, and then try to use the GitHub Actions as well to run tests.
Okay, so it's I mean I've been following, and I see you integrate. You actually say, well, look, here is my testers that run, and I just want to check the coverage. And you go because it's attached to the GitHub Actions. That is where it's picking up its lead from to get the coverage of the test suite. Yeah.
Yes.
Okay. Um, so I think some in terms of it's all built on Python. It's built in the thing. It's for integration. It does unit and integration tests. But what about UAT? What about your UAT tests? How do you uh, is it there as well?
UAT.
Mm.
UAT is user acceptance testing. You are
Yeah, does it
referring, right?
does it check the coverage of it?
Just it's more focused on test coverage and automated testing rather than UAT. UAT has to be done by humans.
All right. I have here from somebody called what's the person name? Oksana. Oksana is asking if one, and I was about to ask you, does it work in combination, or it's just a unit and integration test plus only Python, or only GitHub, or is it a standalone thing?
At this moment, only GitHub, but agnostic programming languages, TypeScript, Python, PHP, Ruby, Flutter, Swift, and everything. Agnostic for programming language, but platform is only GitHub is only supported right now. And for use cases, unit test, integration test is the most suite. for GitAuto, we are, the most good at this
So in
test
a
case.
nutshell, somebody like myself who does not use GitHub and GitHub Actions at the moment, I can't use your tool. Is that the logic behind it?
Unfortunately, no, at this moment, because every startup has to hyper focus on use cases. So right now we only support GitHub. Sorry, I'm sorry for that. But just let me know, if you use the other platforms as well.
Okay, because I mean, yes, because you're talking about something that is built for CI/CD, and immediately I started thinking, oh, Circus CI, all these other ones out there, Jenkins and all these other CI/CD pipelines. So, but at the moment you just stuck on GitHub itself, where you use GitHub Actions and things like that. How so?
But
My
yeah,
question.
yes, exactly. So we only support, in terms of CI/CD perspective, we only support GitHub Actions at this moment. But Jenkins or other, test suites or CI/CD pipelines, we will support that, because we just only need test coverage report, which can be generated everywhere.
Mm.
So we are not tightly integrated with CI/CD pipeline. So we will support other platforms as well very soon.
All right, that's good. That's good to know. That's good to know. I mean,
Yeah,
but
yeah.
I like it. I like what I see. But in order for me to run a POC to see if it will work for me, I need it. I have different pipe. I don't use GitHub Actions or like that. So I would need to literally create a whole other project, just to see it work. But I think going forward, I think you should look at you guys in terms of the whole application. You guys should look at looking at the more prevalent CI/CD pipelines there and things like that.
Yeah, thank you very much.
Okay, so just to wrap it up, and before we wrap it up, do you have anything else you would like to pass on to the audience before you lock off?
Libraries and frameworks, tech stacks are very widely, different from each other, and then so you should have a different tech stacks. So just uh, I love to talk to you, in a separate Zoom call or Google Meet to talk about, discuss about your test case, problem, pain point right now, so that maybe I can help you. So let's discuss.
Beautiful. All right. So thank you so much, Wes, for giving us your time here, and I'm quite sure it's very beneficial to the audience, and like I say, it's a good tool. I look at it; it does good things, but it's just from my perspective, we looking at using that. So I will look to do a POC at some point with it, and give you some feedback. So yeah, thank you again, and it was a pleasure having you.
Thank you for inviting me, Rari.
Okay. So but like I said to you folks earlier on, Jonathon is not with us today. He had some very very urgent work stuff to deal with. And before we move on, again, thank you for Testomatic.io for helping us host these sessions, and we try to bring people on who can give us a real insight into the tech world we live in and how fast it goes. Jonathon won't be here, but like I promise you guys, we have a recording of his session, which we think for you. So by way of introduction, for who don't know, Jonathon Wright, he's the chief AI officer at Eggplant, at Eggplant AI. There's a whole R&D business unit lead at Eggplant Fame, and he has been instrumental in driving innovation and growth within the company's Agentic AI platform. So if you could give me a few seconds, I will get recording of Jonathon's session running for you guys.
Hello and welcome to my session on AI assurance, agentic AI with computer use automation. So I've been in the automation landscape for the last 4 decades. Hello and welcome to my session on AI assurance, agentic AI with computer use automation. So I've been in the automation landscape for the last 4 decades, starting in the early 90s. And more recently, for the last 10, 15 years, I've been building AI-infused systems. So what does that really mean? Well, when I moved to Santa Clara in 2015, I was building out testing tools that were using things like model-based testing, but also using technologies such as traditional machine learning and algorithms to actually help generate tests. And then 2017, Eggplant released a model-based testing solution, which did something very similar based on TensorFlow and was able to generate the next tests before Transformers in 2017. And then more recently in 2022, my team put together and released the first generative AI platform to the market to really showcase what could be done as far as automatic code generation and run automation from the use of natural language. This year, we're proud to announce about our Agentic AI platform, which my R&D team based in Oxford and Cambridge, Santa Clara and Santa Rosa, plus a team out in Penang, and more recently in Madrid, a whole stack of AI doctorates have been putting together what we're going to talk to you about today, computer use automation, large action models, large vision models, and we're going to demystify all of that. But if you want to connect to me, top right hand corner, just join my LinkedIn, and of course, happy to take any questions. So I know we're at Star East, and here's me back in Star West a few years ago talking about really introducing Keysight. Not a lot of people have heard of Keysight, but they're the largest pure play testing vendor on the planet. So even all the way back to the heritage of that 70 plus years ago in 1939, when Bill and Dave created Silicon Valley in the garage by building test equipment that they sold to Disney in 1939, that heritage has continued all the way through to this new decade of exciting new technology. And I'm sure you're wondering, what does this really mean? What does agentic AI mean for me in the future? How is this really going to change the way that I work as a tester? Now, back in 2017, I did a TED talk on cognitive engineering. And you can see some of the terms that I've got behind there. I talk about digital twins, brain-computer interfaces, cognitive reckoning, and a whole stack of other emerging capabilities. And, you know, as we see those emerging things, there's always new capabilities that you can take advantage of. So let's just go back for a second and go all the way back to that original garage. So arguably in the 1930s, they were doing build and test, you know, iterative, I guess, pre-agile, pre-Tom Gilb's Evo in the 70s, 80s. They were really talking about building hardware iteratively, Mark 1, Mark 2, Mark 3. And not only did this revolutionize the way that, you know, both hardware and software silicon was manufactured, and then eventually they moved to Santa Rosa to do manufacturing. So our actual CEO sits above our manufacturing production line. But actually, when they were creating that the test equipment, they used that to enable, you know, companies like in essence Walt Disney, which is where we're near today, you know, to actually be able to do things like the first stereo sound by splitting the audio channels, doing a lot around RF and testing RF and signals. And we still that heritage today. We're still doing quantum computing. We were the first 6G waveform, so eventually, you know, you'll move from 5G once it gets to the 3GPP 30 standard, then it'll move over to 6G, and it'll actually use things like AI, machine learning to do beam forging. So lots of great technologies. And, you know, it's really interesting that, you know, people have heard of Eggplant sometimes because we've been going for about 22 years when we launched SenseTalk, but actually not many people have heard about Keysight unless you're in the hardware manufacturing kind of landscape. So I mentioned, I guess, one side of it, which is all the way back to 1939. And then, alluded to the fact, talking about, I'm going to call it traditional artificial intelligence for a second. But of course, I think, when you think of artificial intelligence, you'd have to give a nod to Alan Turing. And, a few miles from where I live at the moment is a place called Bletchley Park. Now, back in 1950, that's where Alan Turing published his first materials on things like the singularity and the Turing test, all things that we know and have understood today. But I guess you're kind of saying to me, well, what does this really have to do with agentic AI? And then also this term AI assurance. Now, I was lucky enough back in November of 2023 to be at the Bletchley Declaration, which was actually in that building. And we was in that building, and we actually went through and looked at this concept called AI assurance. And the UK government, along with the European Union, really took this AI concept of AI assurance really seriously. And behind that was really about creating a regulation to govern and I'm going to say regulate systems that were built with artificial intelligence. And, you can probably see there, we're talking about McKinsey saying that generative AI could add 4.4 trillion to the global economy. How do we make sure that we can create trust and trustworthiness? And I was involved with the European Union for one of the original papers on trustworthy AI. They're building on that and looking at some axioms such as safety, fairness, and build some regulation around that. So look at how they mitigate risk and also how companies can help regulate themselves. And I'm going to cover in a little bit more detail the ISO 29119 Part 11, which I was part of the working committee for, but also the ISO 42001, which is around every organization needing to do this. And you can see there the Bletchley Declaration signed by a number of companies, and it was part of the AI Safety Summit. So again, this is just some guidelines, but it introduces the topic of AI assurance. And it's really important when we talk about AI assurance because there's 2 or 3 different sides to this. The first side, you could quite easily say, when you're talking, I guess, that Hollywoodized word of ChatGPT, and, you think about it and, it doesn't matter who you talk to, they've all heard of ChatGPT. And, if back in 2017, I was kind of talking to people saying, well, actually, these are the areas, things like accounting and finance and economics and politics, all this kind of very structured landscape. And if you could pan off to the right of this picture, you probably see artists and musicians, and they were the least likely to be targeted. And of course, now with things like Suno and more recently OpenAI's launch of their model, which actually takes 50 times more water consumption than doing a traditional text-to-text large language transformation, you can see that actually things like artists and musicians have actually been targeted by this technology. And so what does that mean? Well, it kind of means 2 things. If you look at something like Stargate, which has been going, they've been building those servers for the last 2 years. It's about having AI infrastructure to support AI workforce replacement. They may call it, optimizing the government. And we did try to do the same thing in the UK, and they realized that we had too much legacy, that these systems would just not be able to actually interact with them, which we're going to talk about in a little bit more detail later. But actually, what we noticed is that everyone today, especially if they're in IT for a second and they're doing, I guess, software development lifecycle, then we've all heard of Copilot for GitHub. And we all, know that the developers are now getting this increased velocity. And I guess that's generative AI. That's this kind of concept that's a small subset of machine learning, which is natural language processing, natural language understanding, and of course, natural language generation. Now, that's only a really small area, but for some unknown reason, large language models have hit the headlines, and now we're all using Copilot in our day-to-day usage. I even have a button for Copilot on my computer, which uses Copilot Plus, which uses my NLP, my natural language processor, on my actual machine to do all that locally. So part of it is we're targeting AI productivity, across the workforce. And that isn't just limited to IT. That's the entire landscape if you're in marketing, accounting, HR, manufacturing, whatever else it is. And then I guess we're all very familiar with what we do, which is, in essence, every day, I guess it doesn't matter what job you've got, you're sending emails. And, back in 2012, when I spoke at Star West, it was the same year that 2012 years was spent every day reading emails just in the US. Now is a scary stat, and I can only expect that's exponentially increased. I don't really read emails anymore, even though that will upset most of the people I work with, because most of the time Copilot reads them for me, or I get an agent, some kind of AI agent, to do the heavy lifting, because the digital grind takes a lot of my productivity when I could be using these AI productivities to help unlock that 20 to 30% based on a capability, a narrow use case, a narrow AI use case of reading my emails and then replying back to them. We all look at this now and we say, okay, well, Jonathon, you've just said 20 to 30% productivity. If I'm a tester, I've got a testing generative AI platform that generates my MCP for Playwright. Okay, well, yes, you're going to get a small benefit from that because you're a tester in the SDLC, in IT, in a organization. But really, you want to unlock more productivity by doing, in essence, cross SDLC collaboration. So what does that mean? Now, actually, I did a recent white paper with IDC, and I introduced this concept of citizen tester to actually say that testing shouldn't just be inside of the IT bubble. It should be anyone. If I work on the manufacturing production lines and this system keeps on crashing, or I think there's an improvement that needs to be made, whether or not I'm doing citizen development or citizen testing, I should be able to be involved, not just brought in for BAT, UAT. So cross SDLC definitely is going to do 20 to 50% productivity gains within, lots of different Turing bots. And Turing bots was a concept introduced by Diego from Forrester, who both Diego and Joachim from Gartner are both doing AI augmented testing waves and quadrants this year. So really looking at, okay, well, you guys keep on talking to us about having these testing Turing bots. You launched one back in 22. Okay, how does that talk to my designer Turing bot? So if I've got a UX design team and they're all using Figma, and they're now using Figma MCP being Model Context Protocol, superseded by A2A, which is agent-to-agent technologies and protocols that have been introduced more recently. But actually, as you communicate between these AI agents, as Tariq would say, are able to communicate between each other and coordinate. So there's a lot to Agentic. It's not just focusing on the agent technology, which has been around since the 90s, but actually it's all about bringing them together. We've seen this before in things like the Microsoft bot framework. We all don't like bots because bots, are intrusive. They don't seem to be effective. Well, we don't need to do that. They can communicate between each other. And so therefore, maybe I don't know about the new European Accessibility Act that's coming into force later this year. But actually, I want to check all of my platforms, my website, my mobile apps, whatever else it is. I need to make sure that it's, compliant against this and we're following the regulations. But maybe I don't want to hire a whole stack of crowd testers. And so that's when suddenly you kind of go, all right, push it out to Tesla or some other crowd testing company to actually bring in an army of accessibility users who can validate this from the human in the loop perspective, fed by these agents, these agentic agents that are, doing some of the work behind, and then needing the human aspect to say, well, what does this mean? If it's this high contrast problem, do we have to change our entire logo coloring system? Whatever else it means. And, things like WCAG and all that kind of accessibility stuff goes straight over my head. And I have to speak to Lavina from who sits on the BCS committee with me, who's very well known for doing accessibility tests for things like EasyJet. So that is just one example, usability. And it could be accessibility and security. I was at a security conference and safety conference in Madrid a couple of weeks back. And, again, I don't know enough about security, but you want to bring these all together. And that's why when we talk about Turing bots and this concept of bringing in, and we use the word autonomous because the idea is they can work independently, But really, when I say that, I'm introducing a kind of concept, and the best way I can explain this is thinking of a hive, right? Is you've got the queen bee, who's kind of, I guess, in charge for a second. And then you've got all these worker bees. And I guess the worker bees over here that are going out, and let's call them deliver for a second. They're going and grabbing pollen and bringing them back to the hive. And they're all communicating, whether that's on magnetic sun. I didn't, unfortunately, sat through that lecture when I was at university. But whatever they're doing, they're independently working to solve a bigger problem, right? And so therefore there's, in essence, I'm going to call it short-term memory, but the worker bees, and then there's long-term memory as well, is this kind of learnings of, well, actually, there's no more pollen in this area. Don't send out a whole stack of people because we've already sent some and they came back and said it isn't. So we don't want the autonomous agents, bots, whatever you want to call them, just hitting the same wall. You want them to have collaborative learning. But at the same time, you need coordination. You need, I guess, corporals or whatever, hierarchical structure you want to use that are able to coordinate the worker bees and the different teams doing different things and manufacturing the honey, whatever you want to call it, right? But whatever's going on, there's this logical flow of sensing and acting and reasoning for a second. There's some basic intelligence that's happening even in these bees. And I'm sure if you watch the Common People, the latest Black Mirror episode, you'll have seen the AI bees on there, and it kind of autonomous, robotic bees. But, I think part of it is this think, create, learn, which you'd have seen in my TED talk kind of written on the board. And this was back from something that I did back in 2015 on leanpub.com/digital, a little white book I published, was the foundation of saying, well, actually, we go through this logical thought process, and it doesn't matter what activity we're doing or where we're doing it across the SDLC. We are thinking and creating and learning. And creating, I guess, is a great opportunity to think of generative AI, because that, in the title, generates something. And I don't like the idea of when people talk to me about large language models, or always referring to large language models, that it's just text to text. Part of it is, we know there's other use cases, image to to text, text to image. We've all used these technologies now, and maybe misused them on LinkedIn to post Lego brick photos and have a quite a carbon footprint behind us, right? But actually, as we go through this, the activities aren't just linear. They're not just one particular workflow, which is very simple to explain. It's very complex reasoning of lots of different systems and systems of systems, right? And this is where I kind of take my kind of OpenAI hat off, because OpenAI knows the world, right? So it's trained on the internet, which in theory should know about bees and hives and all sorts of other stuff. However, it doesn't work for a company that implements software. And most of that software, especially as a software tester, I guess you should be thinking now, is a lot of those systems are very unique to yourself. There's a lot of business logic in there, the special sauce that makes you different to the other companies that only you know about. And this is where I guess the concept of context is king, which, has always been something that, people like Michael and Bolton and James Barker have been very strong about. And I think it's what makes us unique as humans is this knowledge, and I'm going to call it wisdom for a second. And we bring context, and we bring our domain expertise, and we could be very good at aerospace and defense, or, automotive or quantum. We have a specialism that we also bring. And of course, we have our testing capability. And, until now, there's a lot of reasoning models, and, the latest models that have been dropping recently, and there was a codex which dropped off recently from OpenAI, which was quite good at, unit testing. And that's great. Unit testing, I guess, has some test principles, when you're looking at code coverage techniques, but it's not a tester. It can't think outside the box and do all the amazing things what testers do. So we always need AI augmented. We need humans or testers in the loop. There's no way to remove that. You just want to give them superpowers. And this is kind of where I've been talking for the last 2 or 3 years, is saying, well, actually, you can bring a horse to water, but you can't make it drink, right? If you're going to want to get them to, look at doing activities that maybe weren't that exciting, right? Dorothy Graham, the grandmother of automation, who wrote the first line of code for Bell Labs in 1974. Whenever I'm lucky enough to be in a project with her, and she was doing some work for MIT during COVID, and she was pulling the developers apart, because she was able to do things like actually look at requirements and actually look at kind of specifications and understand what the challenges were. And I think this is the skills, the wisdom, the knowledge that comes in, and that's above and beyond is and a lot to do today. Unfortunately, it's probably not around requirements engineering. And going back to Tom again for who did the book with Dorothy, actually, for document inspection. But actually, if you take requirements engineering and things like language for an unambiguous requirements definition language, we've probably regressed quite badly since we moved into kind of modern software development techniques, and maybe the misinterpretation of the Agile Manifesto of working software over documentation without reading the bit at the bottom that said we value the stuff on the right, but we just value the stuff on the left more. But now, with these model contexts, protocol, or whatever, knowledge graphs, whatever you want to call them, complex reasoning over knowledge graphs, you need the knowledge. Therefore, it needs to find this information somewhere. It doesn't matter if it's a transcript. It doesn't matter if it's a whole stack of stories. It can find this information. You just need to be able to expose it to the system. And that information is inside of your private firewall. And it should be, because you shouldn't be sharing your IP with everybody. You shouldn't, anything you feel uncomfortable about just dumping onto a file share and letting everyone use it on Twitter is probably a good sign that what you've got there is sensitive, even if it's your bug reports and maybe the stuff, your dirty laundry, right? So we talked about thinking for a second, thinking activities, which we're really good at as humans. Coding, absolutely. It seems a bit of a low-hanging fruit. And when back in 2022, when we realized that actually SenseTalk was a language-based system, which didn't use IBT, which is image-based technology, so computer vision in essence. It was because it was language, it was really quite easy to syntactically create those scripts. So we thought, well, this is amazing. We can do this. We can generate our SenseTalk scripts. And way before MCP came on the world, we could, fine-tune a model to be able to create tests in SenseTalk and run them. Now, that's great. But the next step which you've got is, once you've got that code, it needs to be able to, understand and learn, a bit like the bees. If, the system changes, so should all the impact on it. Same as requirements, because it's a living documentation. Something changes in the requirements, something changes on a project manager or a product owner saying that it should be 4 instead of 5. Everything has to cascade across. So it has to be able to coordinate the coder agent to actually then update the Gherkin scripts, the SenseTalk scripts, the whatever scripts, right? And so there's a learning aspect, which is the feedback mechanism of once you've executed and run and interacted, that actually it's either creating more tests, it's looping back, and it's changing the test design, whatever else it is, trying different test data to go through different routes. Part of it is it has to learn, it has to be able to get insight to drive the process again, because it's iterative. So they're just very simple use cases, right? I think you can go beyond those in many different ways. But if we take a pause for a second and go back to, well, I guess the original title of this was AI assurance. And of course, straight away, I dropped the AI assurance Bletchley Declaration and talked a little bit about the concept of AI assurance. I'm doing a book later this year as a follow-up to a best-selling book, which we did back in 2020 called with Rex Black, called Artificial Intelligence for Software Testing, Building Trustworthy Systems. That was born out off the ISO 29119 Part 11, which you can see here on the screen, which was the Artificial Intelligence for Software Testing group and standard. And we're following that up with an AI assurance book. And that AI assurance book, of course, will go through and look at things like the 42001, which I'm going to show you in a second. It'll take things like the Executive Order 14110, which has been around for a very long time. And actually, we already, as we're building these systems, we have for the last 7 years, we've had to comply against these. We've got to be able to provide the evidence and explainability of how these systems work, how they've been tested, how they're trustworthy. So I would kind of say that an emerging opportunity, especially within the QA or quality engineering landscape, is to look at AI assurance as well. Most of the systems I guess you are working on today may have components of machine learning or artificial intelligence, or even some generative AI capabilities. And for some of you, I guess you're even building agentic AI platforms today, or at least agents that interact for your specialist area. I caught up with my friend Alon, who created BlazeMeter, who's the co-creator of JMeter, and he's been very excited about Agentic for quite a while. And within KubeShark, he's started building these autonomous agents that will go off and investigate network traffic or optimization issues. And sometimes they won't find anything, right? It might just be an anomaly which they can't report or can't recreate, can't do chaos engineering or whatever. But actually, sometimes they find things which can be working in the background, 10, 100 of them to one human. And so I think there's an opportunity there, but there's also, I guess, there's a mistrust in AI. And I think partially the problem with this mistrust in AI might also be this communication of when you're using the word AI, you shouldn't be talking about ChatGPT. And, equally, you shouldn't be on LinkedIn saying, AI should not be used for testing, because okay, you're correct. If you're using the word ChatGPT should not be used for testing, I completely agree, right? But if you're talking about, algorithms that have been around for a very long time, Monte Carlo, whatever else you might be doing in financial systems that are used every day for risk profiles or whatever else you're doing, well, you can use them very narrowly for certain tasks, right? But without this governance and this framework to actually be able to operate around and validate what these systems are doing. And, you could also talk about validating the AI augmented capabilities like generative AI and the quality of what's being generated there, such as test automation code or test data, whatever else it might be. Or you could be talking about the actual quality of the agentic AI agents, right? How are those AI agents performing in the background? Are they creating the correct information? Or you could be talking about classically, which is what we've all been doing for the last 20 years, building of AI-infused systems, and that could be traditional machine learning and artificial intelligence techniques. So lots of scope here for AI assurance, and I think it's only just getting, I'm going to say, mainstream. It's going to be kind of the point where everyone's talking about it. It's a general kind of discussion point because of, in essence, generative AI technologies back in 2017 for transformers and 2020 or 2021 for kind of the generative technologies that we all think of today, like ChatGPT. But, there's a lot to navigate. If I go, I'd highly recommend people to go to the AI Standards Hub, right? And my good friend Adam, who co-wrote the book, he was there in Paris a few weeks ago with those. But, part of it is you will find, not only for your industry, but, a whole raft of standards and compliance, which you should be following, like Square, as a good example there, or the risk framework that's linked to the government executive order. Now, if you haven't downloaded the book already, you can just click on that link or that QR code. I'd recommend doing it in a browser, and you can just right-click, save as the PDF file. But, I'd highly recommend checking that book out. But also, if we start looking into things like the 42001, which I'm going to spin up in a second, you'll see that a lot of it is around risk frameworks, whereas, the ISO 29119, we've covered things like metamorphic, testing and things like that. But some of it wasn't really covered. So if we look at things like supersonic nozzle and polynormal chaos, which, is a Tariq or Jason question, because, Tariq did his doctorates in this kind of stuff. So he knows how to test AI systems, and he's probably the best in the world at that. But at the same time, some of these techniques are probably not mainstream for everybody who's on this kind of call. But, if you look at some of the unified ones, and I like to think of it really as, how easy you can explain things, right? You saw Shape on earlier on there, but, there's AI Trism. There's so many different frameworks that allow you to kind of operate and govern this kind of technology. And then once you're able to use something like the NIST Gov AI risk management framework, you can find out ways to provide evidence of what your systems are doing, how you're testing them. And I think it's probably quite lacking. I think it was, before the boom, and I guess a lot of maybe a deregulation of AI for a second, and that would be where I see things going. I think the European Union AI Act has really pushed people in a very positive direction, and they're bringing the AI liability in later in this year. There's going to be massive fines. So there's a reason to do this. Whereas I think at the moment, people are running with scissors and building things, and maybe just using ChatGPT or OpenAI's API, or they're using, Gemini, Pro, and not really knowing well, is what it's doing how can I explain what's actually happening under the hood? And a lot of the reasoning stuff that was introduced with DeepMind, but it'd been around as chain of thought, chain of graph for 2 years now. A lot of that is special source that these companies add on top. And this is what we found out when we started building and releasing these systems, that if you look at something as simple as ingestion from structured documents, actually it's quite hard, because even something like Copilot, which we're all familiar to use in E365, part of it is even that really struggles. If I ask it a question, it typically won't be able to get the right answer. And so actually, let's do this with an example, right? So, here's the ISO 42001 first edition. And whilst I'm scrolling down and showing you some of the sections, I'm going to get Copilot to summarize this document for me, because, well, why not, right? And, as I'm doing it, you'll see here, we've got some really interesting stuff around AI assessments. We've got some auditing stuff, which sometimes you think to yourself, oh, it's not that exciting, Jonathan. But, there's also some operating frameworks, some kind of useful things that you can take and actually use, even if it is just terminology. And, to me, terminology is one of the big components, right? It's a component which you need to be able to understand, because, things like metamorphic testing, if it's not mentioned in this document, then there's a good chance that actually it's quite hard for it to get the right definition unless you've provided a definition. So we feed in the ISO 29119, but really you should also feed in all of these other sources as reference information for it to be able to really understand, say, for instance, data quality. So here's its, basic question, but, basic summarization. But I'm going to ask it, what is metamorphic testing? Probably spelled incorrect as well, which is fine because it's a large language model. Now, if it can't find a reference through this document, which, yes, I could use the Control F button and find it, but it would have to go and grab that from somewhere else, right? And you can see that it's got 2 references here, and it's managed to get the reference from our favorite source, Wikipedia, which I could have just changed before this meeting, and also a knowledge of metamorphic testing thing. And so, yeah, okay, that's great. So it's found it, but it hasn't found it in here. And so therefore there's a question around trustworthiness of the things. Whereas if you've brought all that information in and we have multiple knowledge graphs, one of them being a testing terminology ones, which is based on ISTQB and the ISO and BSI and all the other TMAP and beyond ISTQB or ISEB definitions, and actually the glossary of terms, which is really useful to get this information from. But wherever you're getting the information, you need to be able to, have the contextual understanding of testing, contextual understanding of AI, contextual understanding of your application, and also your industry, depending on which industry you're in. So anyway, quick one then around ISO, just to kind of give you a bit of a taste. And, actually, Jason really likes this slide. I think it's the only slide he likes on my decks at the moment. But, AI is definitely not going to go to jail. And, with the liability kind of coming in at the end of the year, and I think you're going to see similar things in the US. If you look at the executive order, they actually talk about cease trading of public companies if, they found malicious intent for AI. So there's a lot of interesting stuff. And my friend Davey, who was at the Pentagon and created a company called Calypso.ai, he was really looking at, kind of how do you regulate those within, financial services, make sure your company's not making insurance claims based on biases, basic things like that, which have been around for 20 odd years. But let me quickly reboot, because I know you're wanting to kind of know, well, what's the answer, Jonathan? My answer will be, it depends, as always. But also, it's all I can spoil this for you already, is that it's all about humans. And, I think we all got to this, and this is 2022, so this is why I look a lot younger, but also you can probably see here, test to GPT, the idea of prompt engineering, you take something, or low prompting, you take some input, and it generates using code generation, the actual code you want, and then you can actually run that code in VS Code or whatever. And then the other thing which we all kept on seeing was these virtual testing assistants, and the people like OpenText have got Aviator, and we've got Eggy. You could talk to it, and it contextually understands what you're seeing. So if you're on a screen and you say to it, well, what am I not seeing in these test run results? It understands that you're on a run for a particular test for a particular system of systems, and it brings in all what we call late retrieval mechanisms for graph-based RAG architectures, which has been kind of replaced now over things like Rare, which is a much more sophisticated format for retrieval. Part of it is that late retrieval will bring in maybe the run history, or bring in run logs, whatever else it needs to bring in. It'll be more specific to what you're seeing on the screen, to make it more of a co-pilot, more of an assistant that can help you with the tasks that you're trying to solve. But it shouldn't just be proactive in that sense. It should be able to go off and do it itself. So we really looked at threading, this prompt threading concept before chain of thought around being able to go off and run lots of billions of permutations of different combinations of things to see if there's something that it needs to tell you, the tester, that there's something wrong. And I think it shouldn't just be there to kind of do a recommendation system for a second of just saying, okay, why don't, these are the activities you could do on this system under test. And this is kind of, I guess, when we started seeing MCP initially, I suppose, this concept of capabilities. There's X amount of capabilities. So I'm going to show you MCP later running in a demo. Okay, part of it is there's only 8 things you can do here, so I'll expose those eight components and allow you to combine them into your recipes. In essence, is a quick way of thinking about it, right? But actually, there's much more to that, right? I think part of it is it's not just about code generation or AI tester coders and AI development coders. It's actually about supporting you with other activities, right? I don't think it's just solely around build and test. And this is where we kind of got it wrong, in the sense of we kind of running with scissors. We went after the autonomous code generation because we thought, we got the best in class sense talk language, and we don't need the page object model, so we don't even need MCP to be able to have access to that information. Everything's visual, so we just need to describe it. And large vision models, in their cognitive vision capabilities like TensorFlow and OmniParser, which I'll show you in a second, very good at looking at screens and understanding them, right, with high accuracy. You say high accuracy, everything, even vision, is still 92-93%, whereas large action models, the ability to action and interact with your stuff, which is what Sam's working on at the moment, and you've seen things like Operator or Claude Computer Use, or Computer Use Agents, which we're going to talk about later on. Those capabilities are getting up to 97% over 25 steps for a OS world kind of landscape. So the numbers are quite strong, but actually, when we went out, and this is another IDC thing we put together a few years back, actually, we got the feedback was actually autonomous code generation, great, but actually test design was a big component for people that needed help, right? And I know this might bring a lot of controversy because people say, well, maybe test design patterns can't be done by these systems. You can't ask, I'm not going to say you'd ever ask a large language model like ChatGPT to create a test, but you would if you started building capabilities that understood patterns like boundary value analysis, equivalence partitioning, whatever else it might be. You could replicate the ability for it to understand, well, what tests could I create? And that's then where the human gets involved and says, well, these tests are valuable. These ones, actually, I'll throw those ones away. But actually, I would never have thought about triple clicking on something, which was an example Jason did for Google search, showing his best of Google, what they wrote for test design, and then what testers.ai created. And there was obviously an overlap, and it's not going to be 70-70. There's going to be a shared pool in the middle, which are really obvious, like, I don't know, just put something in search and click search, right? It's not, there's going to be some overlap, but then there's also going to be these really weird use cases, these edge cases you would never have got, or edgy cases, right? But, back in 2023, there was a real push towards AI augmented testing. And I kind of already spoiled it a little bit by saying, Gartner and Forrester are both releasing an MQ, which we've not seen an MQ in the test automation landscape since 2019, which I was part of the 2017 one, I think. And then, Forrester 2022, they released one, which there was 3 in the top right corner ourselves. So Eggplant, Keysight, and then Tricentis, and of course, Micro Focus now, OpenText, right? But this time, AI augmented testing really is now talking about tools that have that AI productivity, like I said, Aviator from OpenText, those kind of assistants or whatever else. These are kind of AI augmented testing. So it's an interesting new quadrant. Whereas, I think there's a lot of people who've done AI whitewashing of products that, do something like self-healing and now calling it, it's AI. And you kind of go, okay, well, it's just fuzzy matching or whatever. It's not, it's not really augmented that much. It's a very narrow use case. But Jason would always say, and this was last year actually at Star West, when actually, and I'll show you a demo of his platform in a second, he was kind of saying, oh yeah, somebody's running my platform remotely while we were sat there having coffee in the morning. But there was this kind of original concern that actually, well, what's that going to do to manual testing? What's that going to do to traditional test vendors? What's that going to do to, infrastructure and all this other stuff? And the actual real world is that actually, yes, there's going to be a lot of this AI first autonomous AI agents, whatever you want to call them for a second, right? Testing agents, but there'll still be the same amount of manual intervention, right? There'll still be the same amount of test design, same amount of all sorts of other activities, but a lot of it will be augmented, right? A lot of it will be supported by tools. There's not one tool to rule them all. It's using a tool that's going to get you benefits, and a number of other tools, right? So I think part of it is, yes, we're going to see these tools doing a lot of the low hanging fruit, but in actual fact, the heavy lifting, that's when you're going to need this quite complex ecosystem of capabilities. And I guess I did a session with Joe recently, and I'm kind of reminiscing about the 90s and actually looked at the Playwright MCP when it dropped and said, look, well, actually it's a whole stack of case switches, and actually here's my WinRunner code from 98 with a whole stack of case switches and push dynamic buttons and wrappers and all this other stuff doing the same functionality. So what, 4 decades later, we're still talking about automation and the silver bullet of what benefits that's going to have. And I think there is a difference, is that yes, you're right, you can use open source to a certain level. I think open source makes it more accessible, but I think now with things like the SBOM, the software bill of materials, and things like the modernization bills and legalization coming through, there's a lot more rigor around what you can do. And last time I was in India, literally, there was a mass. The big global system integrators were saying there's a massive pushback on bringing IP, based automation frameworks, and we've all seen them, right? I've probably been responsible in the 90s and probably till end of Lehman Brothers, building my own frameworks, because for some reason, I don't know if we didn't trust test vendors or Mercury just had too much of their market share, so we had to create the solution for mercury poisoning, which was selenium. And of course, now we've all got selenium poisoning. The cure for selenium poisoning is carbon tablets, which is just do it differently, I think would be the easiest thing. But part of it is, Playwright or Selenium, just take Selenium for a second, just runs browser execution, right? Doesn't do test design, doesn't do anything big. It's just an execution engine, right? But things are so complex now, and they probably have been for the last 10 years. I think we've probably just ignored it a little bit and just kept on running and building these grand Death Star size frameworks to keep us all in jobs. But now, you need 400 engineers, and my team's got 50 R&D engineers who are all heavy background, quantum physics, astrophysics. These guys are not your bread and butter automation engineers, right? Who are building these incredibly complex systems, and you can only really give them the credit to say, yes, vision, YOLO. Yeah, I've seen some, maybe 10 years ago, I saw Tariq's some amazing work he was doing with gaming, where it literally was detecting real objects. And, my friend Sean Evans, who then created Game Driver, directly interacting with the gaming engines themselves. And, we were all obsessed with this hooking into, the system under test or browser automation, whatever else it is. But actually, this vision aspect, the ability to see, and then this ability to action, and you think of UFO and UiTARS. UiTARS was incredibly powerful, but has again quickly been superseded. And then you look at things like computer use automation. So the ability for things like cloud computer use, things like I'm going to show you in a second, where you can actually interact with complex systems and actually allow them to execute and open up those executions to run reasoning engines to test systems extensively. You can tunnel through via your Citrix or your secure REST desktops on demand. But this only really happens when it understands what's going on, and Microsoft Graph is now, if you debug your machine, you'll notice there's sending GraphQLs of messages of what you're doing in the background, right? Things like the transcript of what I've just done with the Word document, right? Part of it is it's learning how you work as in the industry. And then if we go over to the right-hand side, we're starting to see these governance of how these systems, which have got to have access to massively secure systems, have to be deployed. Everything we build is in Iron Bank containers, is serverless. You can deploy it on anything. You can deploy it on AI infrastructure, but you can also deploy it on just compute only systems, systems that are just, edge ML, with MPUs on a standard laptop, right? Part of it is it has to be able to run and integrate with an incredibly complex ecosystem. And I think this is where I think we're not talking, agentic AI is not talking about generative AI, right? We're not trying to say generative AI, i.e. something that's generating content, a large language model or a large whatever model. The output isn't just enough. You need to have all of this structure. I don't like the word model garden, but we have 50 odd models, and the models that I'm adding are every day. NVIDIA launched one this week called Long, which does 4 million transactions. Deep Code of 14B dropped, which was, incredibly good when it came to reasoning models. The mix of experts models, either Minstrel Small 3.1, again, just extend the capabilities of being able to do this. Even the 400 billion drop of DeepSeek, sorry. There's so much there, and you need to run and choose. You need your model at runtime, right? We have models, fine-tuned models that are DSMs, which I never agreed with, but unfortunately I was wrong, which are domain-specific models, which are just fine-tuned models that are industry-specific, which you see over here, right? And, the spoiler alert for MCP's failure is you really need fine-tuned models to run against the MCP components as well. Yes, exposing the components helps improve the, massively, but you really need a fine-tuned variant that's going to perform really well, and probably a large action model variant as well, because it's actioning what you need to do, whether or not it is taking one of these techniques to actually synthetically go through and pass information between the models and between transitions. So massively complex, and I wouldn't recommend that you go off and build this yourself, right? And obviously get into a lot of hot water when I talk about agents. I think we call agents, right? Agents have been around a long time. You could partially argue that the rise and failure of robotic process automation and really some of the companies that have pivoted completely on the spot, like UiPath, to go from RPA and just remove RPA and now call it Agentic, is there is foundational components that share modern day agent framework, which is I guess the foundations of any really AI based system for a long time. But I think the coordinate function, and I'm going to sit that between the queen bee, which is the neuro-symbolic languaging, and the worker bees, which are the pure act, pure interact, pure sense and understand contextually. I think there's a lot of disconnect between them, right? And, even when I've tried to do, workshops and probably failed, and, this workshop's probably a year and a half old, 2 years old, the standard concept around large language model routers, large language caching systems, the Babelfish example of being able to take in languages. We have a lot of Japanese customers. We're using Japanese variants. A lot of the training, the data that's in there is Japanese. The graphs are in Japanese. There's a lot of, this prompting, you can ask in any language. Part of it is there's a lot of variants, a lot of components. And I don't think it's as simple as people want to think that this is, right? And, I joke about, Clippy and virtual assistants and, really kind of this idea of having a co-pilot supporting you with everything you're doing. But actually, there's lots of increments that are still required before we get to that point where it can do everything you want and probably more. And so with that said, I think, there's a lot of stuff that I would say, even with my previous experience, this is stuff that you can't build yourself. And there's this temptation, I guess, a bit like Innovation Labs is to have an AI labs team and bring all these generative AI people in who are ridiculously expensive, and build this yourself, go through and start building the domain knowledge. The amount of time, even with Paul Gerard putting together all of the different glossaries of terms of every single source of information and then building a knowledge graph out of it, and then actually getting to the point of how do you action equivalence partitioning so it actually does the pattern and not just use the words. It takes a lot of time, even if we don't agree with ISTQB or we don't agree with ISO or we don't agree with the terminology that we use for testing, whatever. But still on top of that, there's the industry knowledge. If you're trying to do this for automotive level, what? Autonomous vehicle radar emulation, something we launched in LiDAR a few years back at CES. How do you test different versions of autonomous vehicles? I don't know. I'm not an industry specialist, but you need to have all of that industry knowledge graphs supporting that. plus all the information that's unique to yourself, unique to your organization, unique to your teams, unique to your different global locations and global implementations of cars and specs and everything else. Plus all that information that we've been looking after for a long time, and all of that information provides it with enough insight and knowledge to be able to actually be able to do something, i.e., recommend tests or generate tests, provide some kind of coverage, whatever those outcomes you're trying to get. The underlying architecture, even this, which is an earlier version of an agentic AI kind of model architecture, has had to evolve considerably over the last 18 months to get to a point where it can support A2A and open protocols, so it could communicate with other upstream and downstream systems that need to coordinate and call on the testing abilities. So I'm just going to summarize in, because I think there's a lot to kind of process, I suppose, in this. And I know a lot of my customers struggle with the word requirements, right? Because if I say to them user stories, they seem to be okay. If I say to them transcripts on Teams, which was a great example Tariq used to give, any piece of information is a source of knowledge, right? And then there's all this information in your tests, your test cases. You can turn test cases into requirements, you can turn code into requirements, you can change the current observability of the system into requirements or requirements to test. You could go backwards and forwards like that Babelfish example, but that is just a source of knowledge, right? The second thing, which I think is really important, is this model garden and the registry around this idea of a bit like a schema registry, Avro, or whatever you want to call it, is this knowledge where it's starting to imply understanding of systems configurations. It gets really quite complex really quickly in the agentic landscape. And, we moved, 10 years ago, we were doing XPDL, extendable process definition language, and business process notation, but it's been superseded by digital twin definition language, and actually digital twin definition language and digital twins still not comprehensive enough to be able to deal with something that's continuously evolving and is an organic kind of living, breathing system representation and simulation for a second. AI assurance, yeah, I think this is the future for a lot of us that are on this call around, actually building governance, asking the hard questions, like how do I know that this system is going to recommend the best policy for the best price to the customer, and how will that still do that in 2 years' time if the system's not being replaced? Industry knowledge, I think it's getting harder and harder. I think these devices, even the NVIDIA NPU kind of edge ML capabilities, these devices, robotics, there's a lot to be able to interact with, a lot of capabilities to drive. They're not just desktops and browsers, even though I'd like to argue that, enterprise doesn't have as much browsers. And if you did the pyramid, UI is just a small component. Really, computer use agents or computer use automation is, all the way from the OSI stack from 1 to 7, right? I think large vision models are overlooked a lot, and I think you have to look and sense where you are. Reasoning is highly dependent on vision models, and of course action models, right? And you can probably see from the observation component here, bit of a spoiler alert, that PyAuto GUI seems to be a go-to play even for Microsoft to kind of make reusable structure. But reasoning, and understanding really helps to provide that higher level of benchmarks of robust ability to drive through systems. And I think large action models are going to just get better. And I think, it's going to feel and look much more like automation. And you'll probably get to the point and say, oh, it just feels like, I press which is what Copilot Plus is for, not to talk to it, is to say, oh, drive Photoshop, edit this video that I've just created, remove all the ums and ahs, and do an AI tuning or fine tuning on the voice. You don't want to learn how to use Camtasia or Photoshop or Premiere or whatever else. You just want it to go off and do it, and it will be doing it in the background. You'll see it do it, and right clicking and going into 8 different things and tweaking the color contrast modes or whatever, right? Correction stuff, and you'll just be sat there going, wow, it's doing it all for me. But that's why action models are so important. I'll show you an example with Omniparser and its understanding in a second. But it also requires spatial reasoning, cognitive reckoning, and neurosymbolic modeling. Or neurosymbolic just means high level, articulation. And I think that's the most important thing, is to be able to understand and give it a mission. Go off and, set up 14 new accounts on my own homebrew, insurance platform, and it just does it. it needs to understand the system. And, you're going to see MCPs being built by developers for internal testers. I hope so anyway. Okay, so I've taken a quick screenshot, and now I'm going to upload what you're seeing on the screen at the moment. And then I'm going to use Omniparser as a large vision model, which you should see will increase my amount of GPU usage as it starts processing. Okay, so now you can see that my GPU has started running, quickly spun up and spun down. I'm using a 4070 here. If I come off here, what you'll see now is that it's identified all of the objects on the screen. But what's important with this compared to something as simple like YOLO, which would be great at object classification, but it has no context. And of course, with things like MCP, Model Context Protocol, you really wanting to understand what the functions of each one of these capabilities are. More so, for the task manager, you'd want to understand how app history actually works and the menus and available options here. The same as the referenceable information that's at the bottom, along with any of these icons. Now, of course, when it's starting, it's identifying everything you can see on the screen, but it's also starting to tag them. So down here, you'll see whether or not it can see an object, and then it gives it a description as well as an identifier. So this is the first stage which you need to take the information from your large vision model and pass that to your large action model. And that unlocks the first stage of agentic based frameworks, is sense and act. So I know it's a lot to take in, right? And you can see on the right hand side there's a large action model, and that large action model is driving hundreds of screens. And this is what Recall was supposed to be doing at Microsoft. We're supposed to start observing how people interact with systems. But in actual fact, the reason why they wanted to do that is to be able to, in essence, I'm not going to say MCP because it isn't. I think it's more that it needs to understand and fine tune it so that it can actually perform well on the large action model itself. What you see on the right hand side, which is, again, this kind of sense where it's looking at the screen, it's trying to solve a large problem, which could be something like play Taylor Swift or something, and it's trying to solve the problem using reasoning. Now, it might find that via a browser, it might find that via something like Spotify, but what it's trying to do is be agnostic. If I can solve the problem, or I even have to install Spotify and set up a free account, it will do that, and then it will teach the long-term memory how to do that again in the future much quicker. So, lot to take in, large action models, large vision models. We all know about large language models, but agentic frameworks, bringing it all together and then understanding this at a multi-system, end-to-end across green screen, legacy, future platforms, AI-infused platforms. Okay, so we bring all of those capabilities together, and what do we get? Well, we get this ability which it can go off and test the application. Now, I've had this kind of vision, and it was something shared when I first joined Keysight, was to kind of give the, as you can see on this left hand side, the quality certification for software, just like we do for hardware at the moment. Obviously quite ambitious, but I'm going to show you, and now I'm quickly going to go from Checky to testers.ai. I'm going to show you how we pull all of this together as something like what we now refer to as vibe testing or vibe coding, and that whole feedback loop. Let's have a quick look. So I said vibe testing. So what does that mean? Well, first of all, I'm going to call it my integrated test environment for a second. And on the right hand side, I have in my chat to an agent, I've just asked it to test the Agentic AI talks today's abstraction, right? So it's loaded the page, it's loaded up a browser proxy. And what you see on the left hand side is it's generating about 700 tests, right? So 700 tests, which are doing things like the accessibility stuff we mentioned earlier, no clear call to action, some standard blueprints of tests, element overlap, so visual testing for responsive view, and it's going through, and those agents are going through and understanding it, right? Because we've kicked it off via the MCP on the right hand side, it's also looking at now finding issues. It's found a whole stack of missing ARIA landmarks. I have no idea what that is. So what it's going to do now is it's saying, okay, well, I've generated these tests. I'm going to run those tests, and then I'm going to give you a result. Now, I've skipped forward to the result, but, it's looked at my website, and it's literally said, okay, got all these issues, some GDPR problems, some 403 errors and missing stuff. These issues have been found by the different tester. Ones are, quite a lot of WSEG ones, some network security stuff. And, it's also got all the steps of all the tests it created, plus some personas. And one of the personas you can see in the corner says, well, actually, you should have added a video to make it a bit more exciting on the intro. But anyway, it's found these issues and it's come back to my idea and said, okay, some WCAG problems, some ARIA problems, some logo issues, some text content, some 403. So what I've got is I've got the HTML page for my talk, and I'm now going to say to it, fix those above errors, which you found in, I guess, the CSS for a second, and then create me a new code. So it's what you see now is there's a star east fix.html where it's grabbing and it's fixing the issues that it's found from the test, and then it's outputting the new code with those issues fixed. So if I go into the other code, obviously I don't know what changes it's made. So I've got to get now to wait for it to say, okay, I've fixed this ARIA landmark, which I have no idea what it is, but I can click on it. And if I click on it, it'll show me in the code where it's actually made that change. And it's added the different tags, things like navigation and stuff, to make it better and easier to do. It's also changed all the other ones. So within this area, it's done the testing and then changed the coding and fixed it. Okay, and hopefully we got some great questions on the live stream.
All right, so there you go. What an awesome session from Jonathon. Unfortunately, like we say, he had a big issue at work, so he couldn't actually be here to take questions. But if you feel your questions in the comment, we'll try our best to get him to respond to them. So, in saying that, on behalf of Testomat.io and myself, Larry Goddard, again, like I say, I'm the creator of klassi-js and that test automation framework. So on behalf of us, I want to thank all of you for tuning in and listening to us. And we will be back July with another session again. So thank you all, and good day, good night, and good afternoon, wherever you are. Thank you all. Bye.